This video is going to be all about the line segment addition postulate. What we have drawn out here and built out in bricks is a line segment with 3 points on it. Remember that any two connected points make a unique line segment. So right here we have 3 unique line segments. The first part is AB, the second part is BC, and then the whole thing is AC. And what the line segment addition postulate says is that the length of AB plus the length of BC equals the length of AC. That's just the formal way of showing that if you add the parts of something, you get the length of the whole thing. So if you add that first part plus that second part, you get the length of the whole thing. All right, let's look at an example of this. So say that AB had a length of 6 and BC a length of 14. AB has a length of 6. Remember, when you're giving length, you don't put the bar above, you just put the 2 letters. So AB length is 6, BC length is 14, and we want to know the length of AC. So we use our formula, AB plus BC equals AC. So we'll plug those in. So we're going to have 6 plus 14 equals AC. So AC equals 20. So we can fill that in over here. So 6 plus 14 equals 20. But we also might have instances where we have variables. So say we have something like for AB, we have X, BC, we have 7, and for the whole thing, we have that it is 11. This is kind of where geometry and algebra start to meet. So let's do the same thing again. So for AB, we're going to have X. For BC, we're going to have 7, and then for AC, we're going to have 11, but what we want to do this time is solve for the value of X. We want to find out what the length is for X. Let's go ahead and plug those values in now. So we write the equation out one more time here. AB plus BC equals AC. So plug in X for AB. For BC, we plug in 7, and for AC, we plug in 11. So subtract 7 from both sides, and we get that X equals 4. But our letters here aren't always going to stay as A, B, and C. So let's take a look at another example here that uses some different letters. Okay, let's go ahead and split these up here. So now we're going to have, for the first part, RS. For the second part, ST. And then the whole thing is RT. Fix that really quick. Okay. So yeah, a lot of times you'll just kind of be building out the equation based on the points that are on your line segment. So you'll do the first part plus the second part equals the whole thing. So let's start with a simpler example here. We'll just say RS is 10 and ST is 19. So then you'll do 10 plus 19 equals 29. Let's do another example that's going to incorporate algebra. So we'll say that RS is 12. ST is X plus 6, and RT, the whole thing, is 23. So we're still going to use this equation here. RS plus ST equals RT. So for RS, we have a length of 12. For ST, we have a length of X plus 6, and for RT, we have a length of 23. So let's plug those in. So we're going to have 12 plus x plus 6 equals 23. We're just adding here, so the parentheses can be removed. So it'll be 12 plus x plus 6 equals 23. Add the 12 and the 6, and we get 18 plus x equals 23. Subtract 18 from both sides. I'll bring this over here. So then we get x equals 23 minus 18, which equals 5. In the next video, we'll do another example of the line segment addition postulate, but we'll do it in a way that's applied to building a Lego fence.